During this segment, we will review adding, subtracting, and multiplying radical expressions. So notice here I have addition and subtraction of radical expressions. Keep in mind that we can add or subtract like radicals. So what is a like radical? Radicals are like radical if the indexes are the same or the indices are the same and the radicands are the same. So let's look at these. This is square root, square root, square root. So each index, they're the same, but the radicands are different. So as these stand right now, these are unlike radicals. Let's though see if we can simplify each term in this expression and then look once again and see if we have any like radicals. Let's begin with the first term, 2 square root of 50, and let's ask ourselves, does 50 contain any perfect square factors? The answer is yes, because 50 is 25 times 2. So let's begin by writing this as 2. And then remember, 50 is 25 times 2, so by that product property, I can write that as the square root of 25 times the square root of 2. Then let's continue, minus 3. What about the square root of 125? Can that be simplified? Does 125 contain any perfect square factors? The answer is once again yes. 125 is 25 times 5. So by that product property for radicals, I can write that as the square root of 25 times the square root of 5, and then plus, again, let's ask ourselves, can the square root of 98 be simplified? Does 98 contain any perfect square factors? The answer is once again yes. 98 is 49 times 2. So you can write this as the square root of 49 times 2. Then by that product property, it is the square root of 49 times the square root of 2. Now let's continue simplifying each term or each radical. So we have 2. What is the square root of 25? The square root of 25 is 5, and then that's times the square root of 2 minus 3 times, what is the square root of 25? Again, it is 5 times the square root of 5 plus, what is the square root of 49? It is 7 times square root of 2. Let's continue simplifying each term now. That equals 2 times 5 is 10, so I have 10 square root of 2 minus 3 times 5 is 15 square root of 5 plus 7 square root of 2. Now look at each simplified term or radical and see if we have any like radicals. The answer is yes. These are like terms because we have like radicals. Same index, an index of 2, an index of 2, a radicand of 2, a radicand of 2. So we can combine these two terms. What is 10 square root of 2 plus 7 square root of 2? That is 17 square root of 2. And then minus 15 square root of 5. Can I go any further? The answer is no, because these are unlike radicals. So here is my result. This is my simplified result. Let's try this once again. We are adding or subtracting radical expressions. Let's suppose I have the cube root of 11 over 8 minus the cube root of 11 over 6. Now, before we discuss whether these are like radicals or not, as they are right now, they are not like radicals. Index is the same as this index, but this radicand is 11 over 8, and this radicand is 11. Notice, though, this first term, I'll call it, can be simplified. I'm going to use the quotient rule and write it as the cube root of 11 over the cube root of 8, and then I'll simply rewrite this second term, cube root of 11 over 6. Now, what does that do, by the way? Look at the denominator of this first term. 8 is a perfect cube. So the cube root of 8, in fact, is simply 2. So I have the cube root of 11 over 2 minus the cube root of 11 over 6. These are now like radicals. I can now combine these two terms, but I do need to have, since we're dealing with fractions here, I've got to have the same denominator. What is the LCD of those two denominators? It is 6. So let's work with this first term. I know 2 times 3 is 6. If I multiply the denominator by 3, I must multiply the numerator by 3 also. So I am saying that this term or expression is the same as this one. If you want to think about it, it's like 3 over 6 is the same as 1 over 2, and that is a true statement. And then I have minus cube root of 11 over 6. Now I can combine. Now just think of it as 3 over 6 minus 1 over 6. What is 3 6 minus 1 6? That is 2 6. So I have 2 6, but I do still have that cube root of 11. Is there any simplifying that can be done here then? The answer is yes. 2 and 6 have a common factor of 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So I can write this as cube root of 11 over 3. And I'm simplified. I can simplify no further. 11 contains no perfect cube factors. So this is a little bit of adding and subtracting radicals or radical expressions. Multiplying radical expressions. Notice in this example, I am multiplying, and we can think of this as maybe a monomial times a binomial. When working with multiplication, we use the distributive property. So we will multiply here by using the distributive property and by also remembering the product rule. So let's take this slowly, since this is our first multiplication example. This is the square root of 7 times the square root of 5 plus the square root of 7 times the square root of 3. And then we can, by the product rule, make that the square root of 7 times 5. That is the square root of 35 plus the square root of 7 times 3, and that's the square root of 21. Now, let's look at each of these, I'll call them terms individually. Can I simplify? Does 35 contain any perfect square factors? The answer is no. We know 35 is 5 times 7. No simplifying that can be done. What about here? Can I simplify the square root of 21? The answer is no. 21 contains no perfect square factors. So can I add then these two terms? The answer is no. We do not have like radicals. This index is the same as this index, but don't forget, for like radicals also, this radicand must be the same as that radicand. So I am through. I have multiplied. Let's try this again. We are now multiplying radical expressions. Suppose I have 2 square root of 7 plus 3 square root of 5, and I will multiply it by square root of 7 minus 2 square root of 5. Think of this, I think it will help if you think of this as a binomial times a binomial. Now, when multiplying two binomials, many times we use the FOIL order, and we can use the FOIL order here. So the FOIL order is first times first, I have 2 square root of 7 times square root of 7. And if you'd like, I can write that down. What is the outside product? I have minus. Now let's go ahead and at least do the 2 times 2. 2 times 2 is 4. And then square root of 7 times square root of 5. Inside product, that's plus. Now that's 3 times 1, still 3. Square root of 5 times square root of 7. And then what is last times last? Last times last, that will be minus 6. And then square root of 5 times square root of 5. Now, when dealing with square roots, there's one thing you should remember, and that is that the square root of a positive number times the square root of the same positive number, that is that positive number. In other words, the square root of 7 times the square root of 7 is 7, and that is true for square roots when the radicand is a positive number. So here I have 2 times. If you want, you can write it as the square root of 49, and the square root of 49 is 7, but this is 7 minus 4 times, here I have square root of 7 times square root of 5. By the product rule, this is the square root of 35 plus 3 times the square root of 35. And then minus 6 times, what is the square root of 5 times the square root of 5? It is 5, just 5. Now let's continue. We're just simplifying each term as much as possible for the moment. 2 times 7 is 14. Notice these are like terms. Negative 4 square root of 35 plus 3 square root of 35. What is negative 4 plus 3? That's negative 1 square root of 35. And you know why they're like terms? This index is the same as that, and the radicand is the same as that radicand. And then minus 30. Is there any more simplifying that can be done? The answer is yes. 14 minus 30. 14 minus 30, that's negative 16. And then minus, I'll go ahead and just write it minus square root of 35. That does mean minus 1 square root of 35. I've simplified as much as possible. These are unlike terms, unlike radicals, so I can simplify no further. At this time, practice adding, subtracting, and multiplying radicals.